Hi everyone. My name is Alessandro Bartoloni. I work for the Italian Institute for Nuclear Physics. I'm working at CERN since many years. It's my pleasure today to have the opportunity to talk about instead activities that I did as a national coordinator of the Moon Village Association for Italy. This panel is named Beyond Borders, United Nations in Lunar Exploration. And this is a sort of recap of the Italian Moon Village Association Space Summer School that we organized to celebrate the International Moon Day last July. Today we meet, there is two friends that also organized with me some event or participated to this kind of event. The first one is Salman Ali Tebdawala. Hi, Salman. And the other one is Paolo Mangini.
Hello.
And they will introduce themselves later. Unfortunately, Malak Trabelsi-Levi, that was one of the speakers in the school, was not able last minute to attend due to the fact that she's actually in the Emirates, so it will be quite midnight, so it's not very easy to be connected. So anyway, the agenda of the panel, it's about having a short introduction of what is the Moon Village Association, and especially the Italian branch of the Italy branch. And after that, we asked Salman to share some insights about, let me say, another event apart from the school that we organized with the Moon Village Association of Germany. Salman is the national coordinator for Germany. After that, I will give you some statistics and, let me say, some insight from the school. After that, we did it, and also very kindly, Paolo Mangili, that was one of the attendants of the school, but also one of the speakers, will replicate one of the most terrific lectures that we have during the school. At the end, if there will be time, we try to have a round table, try to question eventually also with the people from the floor, about how to improve the school, what is the weak point, the strong point of the school. So let me start with the Moon Village Association description. Most of the information, because the association does a lot of things, could be found on the YouTube channel of the association, that is an international one. And so I leave to this kind of link the possibility for you to explore all the activity. Just to make it very short, a description, what is the Moon Village? That gives the name to the association. It is not an access on the moon, so it's not a project for a laboratory in that sense. It's not a village literally, and it's not a monothematic laboratory. This monothematic word is very, let me say, important, because the idea instead is to have something that is could generate global initiative involving governmental, private, public agencies and entities to promote a cooperative and sustainable lunar exploration and the utilization of its resources. This aiming to establish a lunar community on the surface and in the cislunar space. So the Moon Village Association was founded not so many years ago in 2017 to promote the realization of this concept of Moon Village. But let me say that at the international level, it's very well positioned because it's a member of the International Astronautical Federation and also the observer status within the United Nations Committee on the Peaceful Uses of the Outer Spaces. This is, let me say, very important at the international level. And also there is at the moment 800 people from 60 countries and 29 institutional members from 70 countries. This is the most, let me say, is a sort of list, maybe not complete. You see that from most of the countries, there is institutional partner. The beautiful photo, of course, I put it because this is the last one that joined. This is in Italian one. It's the School of Management Bocconi in Milan, and this is their buildings. And okay, about me, I joined a symposium that each year the Moon Village Association organizes in different parts of the world to collect insights and talk and lecturing from many different people. After participating, I decided to join the association. Also, they asked me to be the coordinator for Italy to give you information if you want. The next symposium, the symposium last year was in Los Angeles. The next one would be in Japan, in the nearby of Tokyo in December. So you can join if you want. At the Italian level, I start organizing an activity in which I try to interact with the members and discovering that these members are very active in the space activity as a professional, not only at the association level. So, for example, we organize this event in Bologna using let me say, the shop of one of the members that is an engineer, civil engineer, but is also very passionate for space design. And so we understand the capability of the association to create a network in between the members and also the possibility to interact at the professional level. After that, another important thing is that we open a LinkedIn page. At the moment, we have more than 300 followers. The page was started in June, just before the school. So if you want, this is the QR code, and you can visit to see what we are organizing. So let me say that one of the important things that the association promotes is the International Moon Day. The International Moon Day, of course, is celebrated the 20th July of each year to celebrate the fact that the 20th July 1969, the Apollo 11 mission landed for the first time on the moon surface. But this celebration is recognized by the United Nations. And each year in this period, around the 20th of July, there will be, let me say, the association try to organize many different kind of events to promote, of course, the lunar exploration and the space exploration in general. This year, the topic was about the beginning, the new lunar journey for humanity. And so we organized a school to, let me say, try to have a moment, a two-day moment to really improve in this kind of activity that has got started with, let me say, the Artemis missions last year. But before the school that was held the 24 and the 25, we organized also in collaboration with Germany, MBA Germany, that is here represented by Salmon, another event that was done exactly the 20th of July, and the event was named Global Lunar Odyssey, and Salman will give us some more information about that. But instead, I would like to congratulate Salman because it was, let me say, very he take this very important recognized for his activity in the space sector because he was nominated by the International Astronautical Federation, that Salman could say something more than me, as the emerging space leader for this year, or one of the emerging space leaders, I suppose, a few weeks ago. So, Salman, you have the floor. I stop the screen. You can share yours and talk about this event we organized together.
Yes, thank you so much, Alessandro. Thank you for your kind words. First of all, I would like to thank you and the team for inviting me to the panel today. And yes, about this achievement, I'm going to be receiving this award next week in Baku. It's International Astronautical Federation is an organization that organizes the largest space conference every year. Last year it was in Paris, this year it's in Baku. And well, whoever is a space professional or an emerging space professional can apply. And the deadline usually is in December. So you need nominations. So you could go to their webpage, check out the details, and then, feel free to apply or, get in contact with me and I could probably help you out as well if needed. With that being said, I'm going to move forward towards the presentation. Let me share my screen. All right. Is it visible?
Oh, yes.
Perfect. The slideshow is visible, right?
Yeah.
Perfect. Great. So, as Alessandro just mentioned, I'm going to be taking you all on a recap of the event we did a couple of months back. So the Moon Village Association introduction was already given by Alessandro, so I'm just going to skip this. About myself, just a little bit before we proceed to the recap. I'm from Pakistan. That's where I did my initial schooling from, including my bachelor's in aerospace engineering. along with an exchange semester in the United States. Then I did my master's in space and engineering systems in Moscow in Russia. And at the moment, I'm based in Germany as a PhD scholar. And the focus of my work is on AI-based onboard collision avoidance and multi-spacecraft systems. Other than my academic pursuits, I'm also the national coordinator for Germany at the Moon Village Association. And lastly, I'm also the partnership lead for the Space Safety and Sustainability Project Group at the Space Generation Advisory Council. With that being said, without further ado, let's move towards the event recap. So on 20th July, on International Moon Day, MVA Italy and MVA Germany, we co-hosted this event called the Global Lunar Odyssey, celebrating the International Moon Day. The target audience was space professionals from across Europe, and the idea was to have this event where we could have speakers from across Europe give a keynote presentation during this event, which would then be followed by a brief question and answer sessions. The idea was to have speakers from diverse backgrounds, which would include academia, industry, and research institutions. And the topics that were covered mostly included the lunar space exploration activity by Airbus, Artemis, and others, and also an interdisciplinary perspective from the science point of view, engineering point of view, economy, and health, though we couldn't have much depth on these topics, but it was interesting to know still the topics from the speakers that we had. So the list of speakers that we had included Professor Jan Hams from the Grand Sasso Science Institute. Then we had Ms. Laura Todd, who's the Vice President Space Exploration at Airbus in Toulouse. Then we had Professor Philip Rice, who's the head of Lunar Exploration Department at Technical University of Munich in Germany. Then we had Mr. Giorgio Lorini, who's the head of students for the exploration and development of space in Italy. And lastly, we had Mr. Brendan Mans, who's the member of TUM VOR, a space robotics club led by students at TUM. So obviously, all these speakers are experts in their field, so I would try to summarize their talk as briefly as I can and as clearly as I can. So moving towards the first speaker, Professor Jan Hams, who's a professor at Grand Sasso Science Institute. His talk was on opportunities for breakthrough science with lunar exploration. So the idea is that the moon offers unique properties for science because it has a quietest location for vibrations and radio emissions measurements, and some of the lunar regions are the coldest in the solar system. Both of these properties are crucial for space exploration and scientific activities. So based on this, Professor Jan Hams, along with his team, proposed a mission which is called the Lunar Gravitational Wave Antenna to ESA and NASA. So the idea of this mission is to measure lunar response to gravitational waves, and in doing so, finding out the gravitational wave sources in our galaxy and beyond. And what this would do eventually is to offer insight into the formation of the Earth and Moon system. This here is basically the map of the lunar surface, where the antennas are proposed to be situated to study the gravitational waves. Next, we had Ms. Laura Todd, who works at the Airbus. Her talk was on unlocking the moon's potential. And the idea was to push our limits, how to push our limits by pioneering a sustainable lunar human presence and how to unlock its potential for a better tomorrow on Earth. And the whole idea of her talk was on the why. Why do we need the space exploration? Why do we need these lunar missions? And what is in it for the people on Earth? See, there are billions of people on the planet, and not all may share the enthusiasm or even the understanding of what these missions bring about in our day-to-day lives. So, for example, as a spin-off from the space technology, we have a boost in medicinal technology. We have scientific breakthroughs on Earth. Let's say communication, social media. We all use Facebook, LinkedIn for networking, even Instagram. The weather forecast we have based on which we plan our day-to-day activities, or even weeks in advance. All of this is a result from spin-off from space technologies that we have been doing since the 1960s. And she took it as a step forward and proposed an idea that imagine if we wouldn't have stopped during the Apollo times and we would have gone for the human settlement on the moon. And for human space missions, two important things are energy and heat to sustain life. And since these are not easy to harness in space, which then would have pushed us forward to find alternatives for energy and heat, which would then have benefited the life on Earth, as we all know. Because you see, as of this moment, there are countries on Earth where people are living in intense cold, and based on different economic situations, they have to kind of make a decision whether to go for food or pay for heating, and this would have probably solved the problem. So there are multiple avenues that could be explored forward, but yeah. So this is the plan by the Airbus for the Artemis mission, which is an upcoming mission towards the moon, to have the human settlement on the moon, and there are various missions associated with this. Next, we have Professor Philip Rice, who is the professor at TU Munich, and his talk was on in situ prospecting for lunar water. So his idea was to have water as a space resource because it's not easy to carry water all the way from Earth to human missions on Mars or on the moon, right? So he discussed the value of water in space exploration and also highlighted the current state of knowledge about water, the presence of water on the moon. And in doing so, he did talk about the development of instruments that is going on at TU Munich, which would be used for in situ resource characterization, including water and planetary soil, basically to locate water presence on the moon. And the next step would be to advance our ability to utilize these space resources. So for example, have the equipment to extract water from the lunar soil. This is basically a chart by NASA on how to extract water from the moon and in what ways it can be used for further missions. So in this case, they are mentioning the possible use of water in preparation for rocket fuel, which could then be used to send the rocket back to Earth. Then we had Mr. Giorgio Lorini, who's the head of SEDS Italy. He did talk about briefly about the mission of the SEDS Society in Italy, and which includes the awareness for the general public to understand the importance of space missions, specifically the lunar missions as well, and how it benefits the society in general. Then they are also involved in event organization, which I'm going to mention in just a little bit. They also have technical and non-technical projects going on. And lastly, and most importantly, what they're focusing toward is career opportunities for emerging space professionals or for people who are eyeing at space industry to be their career option. So about the projects, one of the projects that they have going on is Space Talks, where they are inviting professionals from across the space industry to give a talk sharing their perspective on the space industry and how can one grow in the space industry or how can one pursue a career in the space industry. About the event, it's called SEDS Italy Space Conference. This is the conference that is organized yearly. This year, it's going to be held in October 2023. You could check out this event on their webpage. And lastly, he then gave a systematic review of radiation effects on human space exploration and how the radiation affects differently to a male body as compared to a female body. And as you can see on this map, they are spread, SEDS chapters are spread across Italy. And if you are based in Italy or know someone who is in Italy, I would recommend you to check their webpage out and see what they have to offer. And if you can, participate in their activities, that would be a good starting point to building your space career. Last but not the least, we had Mr. Brendan Nance, who's the member of Tomb War Student Club. His talk was on From Dust to Domicile, Sustainable Lunar Habitat Construction Using Solar Sintering Rovers. This is part of Project Rebels within Tomb Space Robotics Society. And this project aims to create a lunar rover for building lunar habitats. And this basically falls in alignment with the European Space Agency's Moon Village concept, where the idea is if we are to have a sustainable lunar presence on the moon, we cannot afford to send humans first and then have them build the architecture for us. We need to have robots do that for us before we step on the moon and start living there. So the primary objective of this rover is to contribute to the construction of lunar habitats. And in doing so, Mr. Brens shared initial results with us where the lunar rover was able to. I'm sorry, I don't have the video with me as of this moment, but I think you could find it on their webpage or details on their webpage. But yes, the initial video showed the results where the rover was able to create simple structures, square, rectangle, triangle, on Earth. And this is the rover that was shown in the video. And as you can see, this rover is being worked upon by the engineers at TURM. So this was a brief recap from my side about the event that we conducted on 20th July in collaboration with MBA Italy and MBA Germany. And yes, that's all I would say. Thank you from my side. If you have any questions, please, feel free to ask me right now or towards the end of the event.
Thank you very much, Salman. I think that if we read some questions, it will be at the end, but thank you for this recap. Anyway, I don't see any question on the chat, so I will restart from the presentation. Okay, can you see the... Right. So this event that we organized together with Salman with MBA Germany was essentially a precursor event because we tried to put in a shorter event, because it lasts a few hours, the same base concept that then we want also to implement in the school. And the idea was that the school, of course, we start to organize some months in advance. We create, let me say, a pool of volunteers that make part of the scientific organization committee that are always, as you see, are all Italians, because the idea was to have a school that was organized by MBA Italy. And anyway, very important from the very beginning, we tried to organize something that will be beyond borders, in the sense that we try to involve not only by direct collaboration, like we did with Salman, but also try to involve in this experience many different countries, not only to have some speakers from any part of the world, but also to give the possibility to people in any part of the world to attend. So we decided to have an event to make in an hybrid mode. We have some people in person, and we have some people instead that was connected on Zoom, like we are now today. And the basic idea is that the International Moon Day is an annual event held for the general public, celebrated across the planet, but also it's an excellent opportunity to educate the public and promote and raise each year at the international level the awareness of the status and prospects for humanity, the sustainable moon exploration and the utilization of the moon, and the need to act together to regulate the activity on and around the moon, so that it will be done, let me say, within the approval of the United Nations. And this event fosters increase the global cooperation between stakeholders worldwide and promotes increased participation in this call of the future generation. So, starting from this definition that is, of course, taken from the Moon Village Association definition of the International Moon Day, the school will push the purposes of the International Moon Day that was focused on the beginning of the new lunar journey for humanity, and also will promote the expertise and research interests of the Italian associate. So we want to start from what the Italian members, this comes from the first experience that they did in Bologna, discovering that most of the people that was in the association has also a very big background as professional in the space activity, and also to create a networking in this field between students and stakeholders. Of course, the other idea was to reflect the characteristic of the association, that is not just to promote one specific field of the knowledge, but to be very, very multidisciplinary and cross-disciplinary as much as possible. So, let me say, this was the program. and it's very, let me say, very dense program. I do not deep to any talk because it will be 2 days, very, very full of a lot of people talking, but I just would like to share with you two main concepts that in a sense are also present in what Salman says. The first concept was that the school topics should present a very high level of interdisciplinarity, because this is in the soul of the association. So that you see, I did this taxonomy, so please don't blame me if I make some cross-section between something not completely correct, but we talk about economy and missions. That means lunar economy and lunar mission. We have some lecturing on governance. We're talking about space laws, sociology. That means how we will manage this very strange situation that will be in the future, to live in confined spaces, in starship, in village, and also about sustainability. That, let me say, is one of the main crucial points that the association wants to promote, the sustainability exploration of the space and of the moon, first of all. Then we also focus on some cultural aspects. For example, also someone remind us that in the talk of Laura Todd, that also was one of the speakers in this school, one of the main points is the communication. And we had a very beautiful lecture by Tema Gatti about how to communicate effectively in this field, but also about anthropology, the cultural heritage that the moon that followed the human activity since many centuries is in our culture, and also some let me say, perspective on the fact that we are becoming, or we will become, a multi-planetary society. This is, in a sense, is compulsory. The humans cannot avoid this type of step. Also, we have a part by science and technology. We face two problems that are very crucial in space exploration. That is landing technologies, how to land on Mars or moons. And the other one is about space radiation. I did this kind of lecture, and for people interested to say something more, there is tomorrow morning, very early in the morning, Washington DC time, a panel on that subject. Then we have a very terrific talk about moon chemistry and geology, done by an emeritus professor of Sapienza University, Giovanni De Maria, and also a lot of lecturing about technology, enabling technology. One was done by Bernard Maltz, that also took in the event of the 20th of July about rovering. And the last, but not least, we have a very beautiful session, an interesting session on architecture, in which we face two different topics. That is settlements on the planet, Moon and Mars, but also it's a very interesting one. I don't say anymore because the talk that we hear from Paolo is about the cis lunar. So the other point that I would like to share with you is that I think that we completely catch one of the main points. The fact that we was able in involve the four pillars of the space exploration, the space activities, that in our perceptions are the space agency, and we have speakers from the Italian Space Agency and the ESA, European Space Agency, the enterprises, because if you want to go to explore, you need a lot of technology, you need a lot of building, testing of things, in a sense that are the base, the foundation for the exploration. And we have the people from two very big, let me say, enterprise or company, European company, Thales Alenia Space, Airbus Defence Space, but also we have some representative from the small and medium enterprise in Italy, New Robotic Car and Peroni Student Engineering, but not also the Wemwell Group from the Emirates, the Astrostrom from Switzerland, and Spacewatch Global from Germany. The other pillar, of course, is the academics and research. We, let me say, also for the fact that most of us work in academics institution, research institution, like myself, was very easy to involve people from Houston University, Abu Dhabi University, the Bocconi School of Management, the Technical University of Munich, the University College of London, the Jagiellon University of Krakow, the Sant'Anna School of Advanced Study, the Center for Air and Space Law, that is a US institution, and of course the Sapienza Università di Roma. And last but not least, the pillar that I think that is the most important, because students and young professionals lead them and transmit the passion that they put in doing the things. We had a lot of student associations that participate to the conference, not only attending but also as speakers. SETS Italy that also participate to the previous event. It's a Space Generation Advisory Council that is recognized by United Nations. Polyspace, that is a student association that is, let me say, bound to the Technical University of Milan, the Politecnico di Milano, and of course the World Space and Robotics that also Salman mentioned. What about participation? Going to some number. We have 72 people registered, including the speakers, but we have a very good ratio between speakers and attendants. You see that most of the people, more than 60% of the people was attendant and 40% roughly speaker. By connection, we, let me say, catch the point to organize an hybrid event because we have 15 people in person, and the experience was really exciting, especially for me, that was hosting the in-person part, and 85% online. The participation, of course, it was an event that it was distributed, broadcasted in several different countries, so we have a maximum participation of 15 people, but we never go below 25 people connected on Zoom. Also, it was an excellent equilibrium if we consider the age. Of course, this is of the school, so 50% of the participants are less than 30 years old, but this is very important. We try to have speakers of all ages, and it was a very let me say, important to have 1/3 less than 30 years old, 1/3 in between 30 and 49, and 1/3 greater than 50. This is very important because the knowledge transmitted through generation is the basic mechanism about knowledge. Okay, just we have also because space, let me say, is as passionate of any said. So we have on the attendance 50% of participants are male, 50% females. Also on the speaker there was a good equilibrium. But the slide that I prefer most is this one, because at the end, when we considering all the possible dimension about geography, that is passport, living country, professional affiliation, because you know we are in a global world, so there are people also. Salman that just said us that is from Pakistan, but is since many years studying working in Germany. The same Paolo that is in Italian. But the student is used to university. You see them 20 different countries were represented. If you include the speakers and attendance, this is very, very good results. So also, of course, if you go deep in the number, if, for example, we take in consideration the leading country dimension, we see that also there was a good result because the Italy take only 50%, while the other 50% was attended, or the speaker was living in different countries, most in Emirates, Turkey, and UK. And also, if you instead take the dimension of the affiliation of the people, speakers and attendants, we have again an equilibrium between Italy and all the other countries, again with a very big participation for Turkey, USA, UK, and Emirates. So, some follow-ups, but the immediate one that, let me say, let us as organized very happy was the five, let me say, students or very young professionals decide to join the MBA. 4 was among the one that was attending the school in person, one instead was attending by remote, and also another very, very good things and very, let me say that it was very important for us that many people use LinkedIn, that social, to share their gratitude and also to let us know that they was happy to participate. But even if you see that in the LinkedIn post, usually my name or the name of Giuseppe Ribaldi is in the acknowledgement. Let me say that this is not really true. The real acknowledgement is for let me say, all the speakers that was so kind to give their availability to, let me say, give the maximum of the effort they did to organize very terrific talk, everyone. So a big thank to have to be, I would like to thank you very much, all the speakers. These are screenshots that I take from the Zoom connection that they had during the conference. I promise that in the future I will also put the name of each one, but by now I was very, very, let me say, important for me to say big thanks. It's not the case that there is not the photo of Paolo Angeli, because Paolo is with us. So, Paolo, I don't want to say nothing about the talk that you did. It was one of the most appreciated of the school. So, please introduce yourself, replicate your talk.
Thank you very much, Alessandro, for inviting me, and thank you very much to the conference for also inviting me. This is going to be a very short and collection of highlights from my previous presentation that I did back in Rome in July. So I'll just share my screen. Can you see it?
Not yet. Yes.
Okay. So we've talked about many topics today. Professor Bartoloni and Salman also mentioned the importance of ISRU, the fact that many speakers over the conference, the MBA school, talked about ISRU, the fact that we will be able to use resources already in space for the benefit of space missions. And I would say, especially in the long term, not only for the benefit of space missions, but also for the benefit of life back on Earth. So that was my preoccupation when I started developing this project here at the University of Houston. I came here in August of 2022, beginning my master's degree. I'm originally from Italy. I graduated in product design last year at the Polytechnic of Milan. And I've been a very lifelong enthusiast, and therefore I couldn't see no reason not to come here to Houston to pursue this degree, which, by the way, is still the only one in the world. Space architecture is a multidisciplinary field, still very young, but very motivated, and we're very motivated to become one of the key assets for the future of humanity in space. And this is not some of the work that you can see on the left that I've been working on, and some of the work also I've been developing here at the Sasakawa International Center for Space Architecture. Here you can see me inside of the spacesuit mock-up you see behind me, doing some virtual reality development and projects. So that let's fast forward to the future, 2030s, 2040s. We see research shows a very crowded future. We see private companies taking a larger share of space in space, heavy launchers flying regularly, and possibly even lunar bases based on ISRU systems. But there's a big problem. Trade studies show that there's a clear demand for large in-space infrastructures. Research has shown that 2030s, by mid 2030s, we will see large ISRU production on the moon, but expansion in cislunar space is still limited by orbital mechanics. And all the studies that have been forwarded by research institutes, professionals, and so on, mainly focus on the production of deliverables. But what I've been focusing on for the past year is how are we going to make those resources available for those who are in space. And so we have to adopt a cislunar strategy, working not only on the moon, which is admittedly the biggest resource situ up there, but also we have to work on the logistics to make those resources available in the most efficient way. This is one of the studies that I've been looking at, for instance, albeit it was done in 2019, we might see some offset due to the pandemic, but the situation still hasn't changed that much. The moon is a virgin territory, to quote the study, is a virgin territory in terms of existing logistics capability. We have no logistics capability so far, and this is what this project is mainly about. So how do we choose the key points for a logistics project for space between the Earth and the Moon? Well, the choices are many, and one of the key assets is to have refueling stations in space to not only assist space missions, but also to make them longer, and also in the future, in the long term, to make them um, designed already in space. The choice came down to two possible locations to begin with. One was low lunar orbit, and the other one was Lagrange point number one, which is located between the Earth and the Moon. And the latter, the Lagrange point one, was the most suitable location because of its more favorable orbital mechanics possibilities, the fact that no launch windows are imposed by the system, the fact that the velocity changes are much lower, and there is an exponential relationship between the velocity change you have to impose to your spacecraft in order to get to a certain location and the amount of payload the spacecraft can carry. In fact, if we leave the Earth, typically to go to the Moon, we have a payload which is about 1/50th of the amount of fuel which is needed. So even heavy launch vehicles are very inefficient when it comes to logistics. So we have to be able to use resources in space. We have to be able to mine them in space, but also to move them to the most suitable locations to use orbital mechanics in the most efficient way. This is the refueling station that was. I'm going very fast because I'm skipping a lot of steps, but I want to highlight the main key points of my talk and the project. This project is going to be included in my final thesis here in Houston. This is the Lagrange points operations and refueling terminal 2035 foreseen configuration, proposed configuration. A refueling platform which is built around a modular and scalable infrastructure design paradigm. And this depot can also be expanded based on the market needs. This is the assembly video of the platform. This was done last year, and the project is still under development. The first module is foreseen to be launched in 2030. And is composed of the main module number one space tug, which is the key asset spacecraft that is going to make the logistics possible within cislunar space. And of course, the destination of this initial module and the following modules is Lagrange point number one. And so all the system is deployed and made fully operational at Lagrange point number one. I'll go over this very quickly. We will use SpaceX's forecasted space Starship greatly because of their forecasted low cost per kilogram of payload. To bring mainly container modules that are going to be used by the space tug vehicle, which is basically a multi-utility spacecraft, which is forecasted to leave Lagrange point number one, go to the Moon, collect fuel that will be mined there by the future lunar bases, especially on the South Pole, as they're foreseen to be there, and then bring the fuel back to Lagrange point number one. The operation has been designed to, and this is merely a concept, but can be a possible solution. It's based on the idea that the space tug, the vehicle that will carry the fuel back and forth from the Moon to Lagrange point number one, will be also refueled already on the Moon. We have to keep in mind that the payload fraction, as opposed to the 1/50th figure I provided before for Earth-based launches, is about 1/3. So for 1 kilogram of payload, we need 3 kilograms of fuel to leave the Moon to get to Lagrange point number one, which is a much more favorable option when it comes to logistics. Here we see some liquid hydrogen mined from the Moon being loaded on board the space tug before the space tug leaves the South Pole. And this vehicle has been designed also to arrive at Lagrange point number one to have enough fuel to make it back to Lagrange point to the lunar South Pole without any other refueling. As you can see here, we see the expansion of the refueling station, which is projected to be able to carry around 1,000 tons of propellant for customers. The space tug also, given its flexibility, can become a multi-purpose vehicle that can be used as an asset to move stuff around and move other assets also in cislunar space. The future that was presented to the MVA back in July was that multiple space tugs can go back and forth on a regular basis to the moon and back, bringing thousands of tons of fuel each year to be then sold to other cislunar space customers and operators. But what resources can we carry from the moon? Well, the research has shown that a lot of resources can be obtained with ISRU processes. This is taken from a NASA research. I mean, not only propellant. Propellant, I think, is the most important asset out there because moving in space is far more complicated than moving on Earth. For instance, on Earth, we don't have an issue related to the amount of propellant with respect to the mass of the spacecraft. While in space we have, so we have to be efficient. But there are also other resources: metals, refined regolith, silica, aluminum, helium-3 even for possible nuclear fusion experiments, water, of course, which can be a way to store propellants in space. But also this research has shown that ISRU has to operate within a larger infrastructures, which is what we aim to bring with this project, that not only takes the refueling station that you have seen, but takes this concept further and develops it within the framework of the 4 usable Lagrange points between the Earth and the Moon. This is what we have today, the kind of supply chain paradigm that we have today. Everything is brought from the Earth, and even the forecasted Gateway space station is mainly based on this concept. This chart basically shows the velocity changes needed to get to the desired location for existing concepts. I mean, Apollo missions, shuttle missions, they were all brought from the Earth. ISS, resupply model, but everything is still brought from the Earth. Gateway will see a slight change in the paradigm with a small supply chain designed to start from the moon to get back to Gateway, but still in terms of quantity, there is still a large disproportion in terms of the amount of goods that are brought from the Earth as opposed to the ones that are collected in space. This project, my project, and that I've been developing here at the University of Houston, looks forward to change this paradigm. And by the 2030s, with the establishment of ideal, at least, establishment of refueling stations to begin with, at Lagrange points 1 and 2, where fuel is going to be collected from the moon and brought there to be then made available for customers in cislunar space, we can start seeing the shift between the brought from the Earth paradigm to the gathered in space and used in space, eventually leading to some resources being brought back to Earth also. These are some of the modules. This is, of course, still not finished, and it has to be taken with the benefit of the doubt, but the foreseen modules are far more than just fuel storage modules. We can have space assembly, space production, industrialization at scale in space, and therefore everything is made possible by an efficient logistics system. This is one of the equations that was investigated in terms of economics. Of course, we have to have a profitable business up there, and I'll come to that later in the policy aspects. But given the fact that profits have to maximize and costs must be minimized, the design leads to the fact, the research leads to a design that sees multiple spacecrafts to enable experience curve effects, maximizing the materials extraction flow rate from the moon, compress the sequence of missions, and also economies of scale to achieve redundancy. One of the key aspects in light of this equation, of course, is that this system being reusable has its costs minimized, because costs are production, transport, price material, which is fixed, and operation. The vision for the 2030s is the expansion to Lagrange points 5 and 4, which are the most stable ones. And given the operation which will be in concert between all of these points within cislunar space, we can imagine also a sort of production flow rate, of production flow from raw materials brought from the moon to semi-finished products and finished products, which are might also be tested already in space at Lagrange point, for instance, number 4. So, as I said, we need to change the current supply chain. The mid 2030s, we'll see the supply chain start, according to our project at least, will start from the moon, and eventually to the 2050s, most of the materials will be mined from space and will be made available with this logistics approach in the most efficient way possible. You can see the supply chains coming from space, and the moon, and also near Earth asteroids, ideally, have much lower velocity changes. Changing now the topic to space policy, given the fact that this conference is a multidisciplinary one, and we love multidisciplinarity here, not only at the MVA, but also in the space architecture faculty. Research that I've conducted also was focused on the relationship between idealistic treaties and pragmatic practices with respect to the political and scenario. We see an underlying conflict between spacefaring nations and non-spacefaring nations, namely less advanced nations. The Outer Space Treaty of 1967, which is the base of everything we do, is definitely not enough for the commercialization of space, and is actually quite limiting. And therefore, we have seen a pattern of change. The US Space Act of 2015, a growing private space industry, which is going into the direction of a more liberal, individualistic approach with respect to spacefaring nations, while for decades, non-spacefaring nations have been opposing this trend. For instance, with the Bogota Declaration of 1966, during which some equatorial countries tried to seize the entire geostationary orbit. That, of course, was just a provocatory act, but it is part of the history of the conflict. So again, we see a national perspective and an international perspective. It is interesting that private companies and public agencies have a sort of interplay which is similar to the spacefaring nations and the non-spacefaring nations in the international context, but switching from the national to the international one, public agencies act in a different way, in the opposing way, when they switch to the international scenario. When it comes to the national context, we see private companies, of course, and public space agencies. They're both important to the space business, and private sector has shown itself to be good at making things efficient. For instance, SpaceX has not invented access to low Earth orbit. They have made it very, very efficient, because LEO flights started in 1962, if we take the USA example. So another approach was to projects, of course, that was shown during the research, was the platform versus one-off efforts in space. NASA used to do one-off projects as opposed to SpaceX, for instance, and other space companies. They are looking for modularity. The second one being more efficient, but the first one still necessary when it comes to disruptive innovation. And both things are important. So this is what the approach that was suggested for this project, to have very high risk at the beginning of each crucial phase, and then a lower risk as we proceed and make things efficient, and private people come in. For the space architect, I've listed.
As moderator, you know that my critical role is to remind you that you have 2 minutes, 1 or 2. Okay.
I don't need more than a minute. Thank you.
Okay, thank you.
The 4 key points that I want to bring forward to this discussion is that one-off efforts, for instance, have to be carried earlier during the ConOps phase. We have to have a modular design all along, making things efficient, relying on redundancy. On the political side, we need international collaboration. We have to share the benefits to avoid a conflict between more developed nations and less developed nations who are going to claim the benefits of space. And we also have to have virtuous cycles, such as more efficient logistics to make things possible. And so, as you can see, I didn't need the 2 minutes. So this ends my presentation. So thank you very much again for having me.
Thank you, Paolo. Thank you very much. I think that from the Zoom, they have a lot of questions for you. And I don't know, maybe you can contact you if there is no time, but if there will be time, I will conclude with 2 things. First of all, I will leave some space to Salman if you want to, maybe also because it was a coordinator of the MBA, if you want to give to try to give an answer to this question. So I can leave the floor to Salman to say something about what you think is to be appreciated by the school method organization, but above all, what you think has to be improved, what can be do better in the future. And so please, you have a few minutes to share your ideas about that, please.
Okay, all right. Thank you. So unfortunately, for personal commitments, I didn't be there in person, but yes, I did. I was there online. And what I would say is, as we all like to say this word a lot nowadays, the multidisciplinary approach for the conference was a really interesting way, because you see, a lot of the students who are aspiring to have a career in the space industry do not realize that learning orbital mechanics isn't the only way to enter into a space career. And the kind of speakers you had in the school showed the diversity from different aspects of how one can enter into a space career. Even people for whom the boat has sailed, probably, who have already spent their initial education on, arts, economy, policy, they still have a chance to be part of the space industry. And specifically, as Paolo mentioned, we have big investors coming in the space, right? It's becoming more and more commercial, the space industry. This also then brings on the opportunity for young professionals from different areas to, participate and play a role in the growth of the space industry. So my final comments would be to continue to have this kind of event every year, and because this not only provide people the opportunity to understand what's going on in the industry, but also provides a valuable networking platform, which is essential to the growth of their career.
Okay, thank you very much. So I think that I can conclude this panel there, so that there is some question that we can try to answer with just one slide that is about, let me say, an invitation to some event okay, thank you very much for the attention, but also if someone is interested, I say, of course, not for to just have some information on the school, but because this would be, let me say, opportunity for networking, to know people in person, to organize a school next year with more and more contact. The school will be presented, and also I think that also Paolo and maybe also Salma will be there in an interactive presentation, the next International Astronautical Congress in 2023, in I think session D24. But the interactive presentation point of the good point is the fact that it is possible to present essentially every time, because the presentation is there on the screen, so we can meet in person and give the presentation. But let me say, also makes a network, and also especially because we are now in an event that is, of course, US based, there will be also a virtual poster in this virtual forum meeting of the Lunar Surface Innovation Consortium, always about this kind of schools, but it could be again another way to to make some networking. I'm very happy that this kind of, let me say, association and consortium take into account the possibility to present this kind of events and this kind of activity. So now we have 10 minutes for try to answer the question. Paolo and Salma, you see the question in the chat?
Yes, I can.
Oh, yes. So you can try to start if you want to answer the one that you prefer, number 1 or 2.
I see 2 questions from Robin. The first one is there financial feasibility in emerging space commercialization sectors like asteroid mining, lunar tourism, and a space for space economy sector? This is a difficult question because there are so many aspects to it. Well, asteroid mining is one of the key topics that we've been hearing about for the last few years. It's not a new concept because concepts about mining have existed for decades. But of course, the question is sustainability. One of the equations that I've shown takes into account the profit revenues aspects of space mining, but that's not just it. There are more and more aspects to it. And what I've been focusing on more is logistics. So how do we make things available? ISRU, which is in situ resource utilization, which is basically the mining aspect of space mining, has a lot more to it. And there are a lot of aspects, and it's a very diversified discipline on its own. I think both things are necessary, ISRU and its logistics, in order to achieve sustainability. But of course, to have more figures, more studies are needed, and more testing is needed. One of the key issues, of course, is to lower the technology readiness levels, which is to make things feasible on the technical level. So I'll leave Salman also some space to answer.
Yes, Salma, you can choose number 2 or try to give your idea, also your perception, number 1, your choice.
No, I think Paolo perfectly summed up the answer for number 1. I would just like to add the technological readiness level that Paolo mentioned. So you see, before SpaceX, before Starship is still under development, right? But before Starship, we didn't think much on how we can have a base on Mars. But Starship is being constructed with the idea in mind that, we can have a settlement on Mars, and lunar settlement is just one step towards it. So technological readiness level has to be there to have these processes such as asteroid mining going on and have them feasible and financially suitable. The second question says, what factors should be taken into account when evaluating investment opportunities in these unconventional space ventures? That's a very good question. The thing is, it is a risky business, I would say, but we don't have many examples. So you see, all of the commercial space ventures that are out there, the big ones especially, they have been self-financed. So you can see that the investor confidence is pretty low in big scale, but that is changing. And but still, most of the investments are coming through like European Space Agency or NASA in the US and Europe. So I to be honest, I'm not qualified to mention or comment on this, like how to evaluate, but I would say, like any investment, this comes with a risk. However, the risk is kind of greater in the space sector. So you have to really know the person who's behind the project that you're going to invest on, and there has to be a good MVP, the minimum product that is there that you could bet on. Because for the research phase, the institutes are already getting the money to conduct researches. But if you are to bet on a product, you have to see the product and it has to be tested. And in order for it to be tested, you again need the money. That's where the organizations such as ESA and NASA, they come in. So it's kind of a mixed, interconnected loop. But yeah, you have to do your due diligence, obviously.
May I add one aspect to it?
Yes, please.
On the due diligence aspect, I mentioned before the TRL, the technology readiness level. This is one of the key factors to take into consideration when evaluating investments. And the higher the TRL, the safer the investment, of course. You have to check the information you have, of course. And I think you have to look at the success rate of previous missions. If you have a high TRL, it's much easier that the mission or the type of mission or the technology has already flown previously. For instance, CubeSats. So that's one of the aspects. You have, as someone said, to do your own due diligence.
So let me add one thing. I try to expose myself on number one, since I starting from what you say is both that the technology readiness level is the base to understand what is the for real and for not. After a while that I'm of course studying, hearing, I think that from the three aspects that Rabin proposed us, I think the most promising one is lunar tourism. I think that we will see a lot on this field because there is many efforts both in Europe, especially in the US, to construct some hotel or something around the moon, around the Earth. Maybe not lunar tourism in the sense to stay on the surface, but I think that the space tourism is going to be the very most promising of the three. Instead, from the number two, let me only say that I try to say again in another way what I just said before, that in the future, to be really reliable in doing investment, all the firm, all the enterprise should rely on analyst generation that have interdisciplinary capability to analyze the market. This is why it's important, because space is a very complex market in which there is a lot of discipline that interleaves one with each other. So this kind of, let me say, 360-degree knowledge will be crucial for analysts and people working in this kind of sector, and also people that we suggest about the investment, of course, the business people. This is what I think. Okay. There is another question. How do private aerospace companies collaborate with public entities?
Maybe I can provide some background to this. I've investigated this aspect quite a lot for the project I've shown before, and I've already shown some slides about the topic. I think the collaboration between private and public can be based on the type of innovation each party is interested in. Public sector is very good at making high investments at the beginning in high-risk projects. Therefore, lowering the TRL, enhancing the TRL from the most reliable levels to the mid levels, and then the private sector can come in basically to make things efficient. This boundary is not very well defined, of course. There's not a clear boundary, but there has to be some kind of a symbiotic relationship between the two. There is also one key aspect to it, because the private sector is good at economies of scale, as opposed to the public sector, which often does very large projects, one-off projects, bespoke initiatives. And therefore, in this case, industry supply chains cannot be built in the same fashion as private industry does, because the private industry looks at profitability and therefore at the size of the economy, at scale, albeit it might be not relatively big, but it's still bigger than only a public initiative. You need both, as I said before. But again, the key discriminant, I think, is the type of innovation each party does. And I think public sector has to do the radical innovation in early stage investments, take the biggest risks, and then as the risks are lowered and more discoveries are made, the private sector can come in and make things efficient.
And Paolo has beautifully summarized this. And just to add a little to this from a personal experience, first of all, you need to attend these international conferences or events for networking. That's why we emphasize that networking is the most important, because that's how you get the personal connections, and you can reach out to the people directly and offer a chance for collaboration first. Secondly, looking at it from a more microscopic point of view, let's say, let's take two cases. One, you have a chance to put in a proposal for funding from NASA or from ESA. That's where you could collaborate with these public institutions, which could provide research capability to young startups. And the startup has an idea, the research power is with the public institutes. Second, along this way, in Europe, I'm not sure about the US, but in Europe, most of the companies, startups, or even big companies, they they hire students to do master thesis, even PhD thesis. And those topics are directly linked with the kind of work that they are doing, which goes hand in hand and increases the TRL level of the research to some point. So it all depends on how you look at the problem and how proactively you approach people and with the ideas that you have.
Okay, thank you very much. So the discussion is very, interesting, but I think that we have now finished our time, and I think that thanks the audience, thanks Paolo, thanks Salman. Hope to see you soon somewhere. And okay, that's all.
Thank you so much.
Thank you for having us. Yeah, thank you. See you in Baku probably.
See you in Baku. Yeah, right.
Yeah.